This is the first in a set of videos reviewing for the second exam in Calculus 1. What will be needed on a lot of these questions are the derivative rules, starting with the power rule, which we use quite often. It's the one where we bring out the exponent to the front and subtract 1 from the exponent. There's the product rule, which goes first times the derivative of the second plus the second times the derivative of the first. We have the quotient rule that goes low d high minus high d low all over the square of what's below. And then we have all the different trig derivatives. The derivative of the sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. And the derivative of secant is secant x tangent x. Derivative of cosecant is negative cosecant cotangent. So you might make note of the fact that all the cofunctions start with negative out in front. And that happens for all the cofunctions, like so. So you might keep that in mind if you're trying to remember which ones are which here. Alright, so all those derivative rules you will need to know and know how to apply to do questions such as the ones here on the review. So the very first example we'll look at, let's see, say number 5, where we have y equals 4x squared plus 8x plus 2 x to the negative third. And we need to find the derivative y prime. This is all going to work by the power rule we had up above. We take the derivative term by term. So we'll bring the exponents to the front, subtract 1 from these exponents here. So we're going to get 8x to the first power plus 8. When we take the derivative of x to the first, subtracting the 1 from the exponent of 1 just turns into 0, and so the derivative of x by itself is just 1, so this is just going to be 8. I'm going to take the derivative of that one. And then finally, now it's going to be minus 6 x to the negative 4 when we take the derivative of that term. And this should be what the answer key has listed for this question here. An alternative way we could write the final answer is to make use of the negative exponent property to write this as 6 over x to the fourth instead. So the answer key has this one here, but this one is also equally as good. And very often we do like to write back with positive exponents by using that negative exponent property. Alright, well, another one we could do is say number 7, where we have r equals 3 over s cubed minus 9 over s. To this one, we need to first write with negative exponents. Step number 1, so we'll write r equals 3s to the negative third minus 9x to the negative 1. Then we can take the derivative r prime by, again, we'll move this exponent to the front, subtract 1 from the exponent on both of these. So the negative 3 times 3 is negative 9, s to the negative fourth, plus 9, since I'm multiplying negative and 9 and negative 1, s to the negative 2. Okay, and so I'll go ahead and write this with exponents back in the denominator. So we'll have negative 9 over s to the fourth plus 9 over s squared.